Okay, so an example of a matrix, 3x4 matrix in reduced echelon form. So it's going to have 3 rows, 4 columns. And what's true about reduced echelon form? Let's get the triangle, ones and zeros. So we're going to have 1, 0, 0, 0, 1, 0, 0, 0, 1, and then you can put anything in that last row. So you can put any numbers you want, 5, -2, 7. Yeah, so the 3x3 matrix on the left here has to have this form. And then this column, you could have any numbers at all. Even 0. Yep.
Yeah. Can I get you to a point?
Why?
He has the triangle form and he has the anything row.
Oh, yeah, but that's an echelon form and not a reduced echelon form. Close. Okay, so in general, what is a leading entry in a matrix? The first non-zero number in a row. Yeah. What? Yes, leftmost is probably better than first. Leftmost non-zero entry in a row. Okay, if a system has a free variable, how many solutions does it have? Infinite. Okay, so you need to give yourself a score out of 4 points. You get 1 point if you wrote a question, 3 points for each correct answer, and if you got a question wrong, you can get that point back if you have taken notes on the section. Yeah.
Copy your answer off of my answer?
No, I didn't. That's funny. What's that? So 1 point if you wrote a question. You get 3 points, 1 point for each correct answer from the quiz. And you can give yourself an additional point to get up to 4 points if you took notes on the section. Yes.
Did the vocabulary,
that counts as notes, yeah.
Yeah.
You did all the vocabulary? Okay. No, it's okay. Okay, so you can get up to 4 points. Mark on the folder next to today's date your score out of 4 points. Okay, so today we're going to refine and extend the methods we learned last class in section 1.1 regarding solving a system of linear equations using a matrix and elementary row operations. So last class, we used the 3 elementary row operations to put a matrix in triangular form, is what we called it. That form where you have zeros below the diagonal, its official name is echelon form. We made it so that we had zeros underneath the diagonal, and in pursuit of that goal, we worked column by column from left to right, knocking out any entries below the nth row. If we're working on the nth column, you want to knock out everything below the nth row. Okay, so it turns out that what we learned last class, while sufficient for solving the system, because you can then use back substitution, is only half of a complete algorithm often referred to as Gaussian elimination, named after Gauss, famous mathematician. So what we've learned so far is called the forward phase. The goal of today is to finish the algorithm, and this part that we're going to learn today is the backward phase. And you do this part after you get the matrix into an echelon form. Okay, so the goal of the backward phase is to make all the leading entries 1, and to make each leading one the only non-zero entry in its column. Okay, and that's called a reduced echelon form or a row-reduced echelon form. So to obtain a reduced echelon form, you start with any echelon form. So you're going to have to do all the work we did last class, get it into any echelon form. Yes?
If it's in echelon form, you can always go to reduced.
Yep. Yep. So start with any echelon form, and then you're going to work column by column from right to left. That's why it's called the backward phase, right? You do the first phase, you go column by column, left to right. Then you work column by column, right to left, eliminating all the zeros above the diagonal this time. Okay, so we'll do one completely forwards and backwards together, and then there's a bunch of work for you to do to practice and get all the rest of the details from the section. Okay, so I need to create the matrix that goes with this system of equations. So I got to put the x variables in the first column. So I've got 2, 0, 3. Then my y variables are 0, 1, 6. My z coefficients are -6, 2, -2. And then my constants are -8, 3, -4. Okay, so I need to work column by column, left to right. At this point, this is the forward phase, what we did last class. I want to knock out all the entries below the 2 in the upper left. So I already have a 0 in the second row, first column, second row. So I'd like to knock out this 3. So one handy thing to do to help you knock out values is to make the leading entry of each row a 1. So it's handy to do that first. Your textbook actually does it later, but I think it's easier to do it first. So I'm going to do it first. So my first step here is I'm going to make my leading, what? Cut row 1 in half, exactly. I'm going to say take half of row 1, and that's going to become my new row 1. So that's one of the allowable row operations. I could also multiply my first row by -3/2, add it to the third row, and that would be my new row 3. But since part of my goal in the backwards phase is to get 1s, I might as well just do it now, right? So I'm going to have 1, 0, -3, -4. 0, 1, 2, 3, and 3, 6, -2, -4. Equivalent to. Swap 1 and 3, why would I do that? I'm working column by column, right? Left to right. My first goal is to get all zeros in the leftmost column below the leading entry. So you're jumping to a new step, which might be fine, right? But the algorithm says work left to right, column by column, knocking everything out below the what's called the pivot. Multiply row 1 by -3 and replace, that'll be my new row, add it to row 3 and that'll be my new row 3. So I'm going to do -3 row 1 plus row 3 gives a new row 3. So I'm the only row that changes. This was a sticking point last class for a couple of groups. The only row that changes is row 3. That's the only new row I'm creating. The other 2 rows I just copy down. 1, 0, -3, -4, 0, 1, 2, 3. The only new row I'm creating is row 3. It's the only thing that gets replaced. And you can write it out if you need to, or you can do it in your head. You say, okay, I'm going to do -3 times row 1 and add it to row 3. That's my new row 3. So -3 times 1 is -3, plus 3 is 0. -3 times 0 is 0, plus 6 is 6. -3 times -3 is 9, plus -2 is 7. -3 times -4 is 12, plus -4 is 8. Does that step make sense? Okay, so I have completed the first goal. I was working on the leftmost column, and I made it look like 1, 0, 0. 1 with the leading entry, 1 is the leading entry, and 0's all beneath it. Okay, so now I move on to column 2. Column 2. I have a 1 in the diagonal position already. That's great, right? And I need to make a 0 beneath it. So how do I knock out that 6? -6 R2 plus R3 will give me my new row 3. So the only row that's going to change here is row 3. I can just copy down rows 1 and 2. And row 3, do -6 times row 2 and add it to row 3. So -6 times 0 is 0 plus 0 is 0. -6 times 1 is -6 plus 6 is 0. -6 times 2 is -12 plus 7 is 5. -6 times 3 is -18 plus 8 is -10, -5. Thank you. Say that again? Yes, yeah. So I'm done with column 2, right? Oops, I copied something wrong here. It's supposed to be a 1. Okay, so column by column. My leftmost column looks like 1, 0, 0. That's what I want, right? My second column looks like 0, 1, 0. Awesome. I have a 1 in the pivot position and 0 beneath it. So in my last column that represents a variable, I want that diagonal, the number on the diagonal, to be a 1. Divide by -5 or multiply by -1/5, same thing. Yep. So my next step is going to be -1/5. Row 3 becomes my new row 3. So I've got 1, 0, -3, -4, 0, 1, 2, 3, and 0, 0, 1, 2. Okay, so this is now an echelon form, right? I have numbers on the diagonal. I've got the zeros and the little triangle beneath it. This is echelon form. It's not quite reduced. I finished the forward phase. But I added one little thing to what we did last class in that I made the 1s. I made all the leading entries 1s, or last class we left them as whatever we wanted. Okay, so my next goal is to work backwards, rightmost column left, rightmost column that represents a variable, right? And I want zeros above the pivots, right? So above the diagonal, I want zeros. So I want to knock out this 2 that's above the 1. How do I make it a 0? Yes. Yeah. So I'm going to say row 2 plus -2 row 3, or just -2 row 3. That will be my new row 2. I want zeros here and here. That's what I'm working on right now. And in this particular, right now I'm working on that one. I want to get rid of that 2 and make it a 0. So I multiplied row 3 by -2, add it to row 2, and that'll be my new row 2. Okay, so row 1 and row 3 stay the same. It doesn't matter. It doesn't matter. I do that because it helps me. It just helps me keep the algorithm straight. That the thing that you take a multiple. Don't worry about it. Okay, so then multiply row 3 by -2 and add it to row 2. So 0 times -2 is 0 plus 0 is 0. Right? And then that happens again here. 0 times -2 is 0. Add that to 1 and you get 1. And then -2 times 1 is -2 plus 2 is 0. Yeah. -2 times 2 is -4 plus 3 is -1. All right. So I really just have one step left because my second column, my middle column, is already perfect. So the only thing I have left to do is knock out this -3. I'm working in the third column, so I should use the third row to knock it out, right? And the reason that you use the third row is because you're not going to mess anything up because the third row has zeros all in it, right? So you won't mess anything up earlier in row 1. Magic, yeah. So what am I going to do? How do I get rid of, yeah, R1 plus 3R3. You got it. And that's going to be my new R1. Okay, so R1, I'm going to copy my 2 rows that stay the same first. 0, 1, 0, negative 1, 0, 0, 1, 2. Okay, so multiply row 3 by 3. 0 times 3 is 0, plus 1 is still 1. 0 times 3 is 0, plus 0 is still 0. Yeah. 3 times 1 is 3, plus negative 3 is 0. 2 times 3 is 6, plus negative 4 is 2. So now we're in reduced echelon form, and you can read the solutions right out of the matrix, right? If I now translate this to a system of equations, this says x equals 2, y equals negative 1, z equals 2. Sure. Yeah, I mean, yes, that's good, generally good practice to check your solutions, go back and plug those all in. That's always good practice. Yeah. I'm not going to do it right now, just to save a little time.